Today, I'm going to discuss the topic user-defined function. Before starting this topic user-defined function, first we have to know why using function is advantageous in a program. Function is used in a situation where same set of instructions you have to execute repeated times in a particular program. So far, the program that we have written in our laboratory classes, we used only one function. We have written only one function, that is main. But inside from main function, we have called many other functions, just like printf, scanf, pow function, square root functions. All those functions are already defined in a library header files, or header files, just like stdio.h, math.h, etc., etc. But today, our objective is to learn how to write a user-defined function and how we can write our own functions in a program. A program can have n number of functions, but the starting point of the program is the main function. If your main function is in line number 50, that means your starting point of the program is line number 50. So consider a situation. Suppose in your room, in this room, we have 30 machines, 30 computer PC. What are the steps for turning on a particular machine? First step is you have to switch on the power button. Second step, you have to switch on the CPU. And third step, you have to provide the password to turn on the machine. And these three steps must be followed for all 30 machines to turn on. Suppose you appoint a person, the name of the person is John, and you define these three steps to John so that when you call the person John and provide the machine number, the John will follow the three steps to turn on that particular machine. So these three steps that you have given to John as a set of instructions, you need not to define each and every time. You need not to tell John each and every time these three steps, because once you have defined these three steps to John, John knows how to turn on a particular machine. Only machine number is required, because he must know which machine he has to turn on. So who is this person John? John is no one but a function. Consider the real situation that you already implemented in the lab class. That is the calling of pow function. When you call the function pow, you provide the value x comma y, and the pow function is giving you back the result of x to the power y. You need not to know how pow function works. You are not bothered about the functionality of pow functions, because you are very happy with the result of x to the power y. And if your program requires to calculate x to the power y 10 times, you need not to write the code of pow functions 10 times, because you have functions available. You are just call the function pow when it is required to calculate, and you have used this. So depending upon the requirement, we can write our own functions in my program. And a function can have, a program can have n number of functions. Must be number is finite, but we can have n number of functions. Today, we are going to learn how we how we can define our own function, that is called user defined functions. So what is the definition of a function? As a conclusion, we can say a function is a self-contained block of code that performs a well-defined task. That means turning on a machines. I declare 3 steps to turn on a machine. So this is a well-defined task. First step is you have to turn on. Second step, you have to turn on the first step is you have to turn on the power button. Second step, you have to turn on the CPU. And the third step is you have to provide the password for turning on a machine. So this is a particular well-defined task which you have defined a person named John. And when you are calling John, John will do that work. And you must have to provide the machine number. One more important thing in this regard, I must have to mention that a function cannot work with its own. It must have to be called by some other functions. So the function which are calling another function is called calling function, and the function which is called by some other function is called called function. According to our example, if myself is calling the function John, myself is called calling function. John in this example is called called function. Two types of functions are available in C. First one is the library functions that we already used in the previous programs, and the user defined function. This type of functions today we are going to learn. What is library functions? The function that is already defined by the system, need not to developed or written by the user, but the user defined function has to developed or written by the user / programmer. So each and every C program must have a function, that is the main function, and the main function is indicated as a starting point of the program. So if my program has 10 functions, at the time of execution of the program, it starts its execution from main. If it is line number 40, then it starts execution from line number 40. So before starting the discussion, before moving to the next slide, that is slide number 3. Now I am in slide number 3. I must mention, when I define my own functions in a program, I already mentioned a single program can have n number of user defined functions. I'm going to explain the user defined function for only one cases. You have to follow the similar steps for all n functions. So for each and every user defined functions, it should have 3 steps. It must have 3 steps. What are those steps? First step is function declaration. Second step is function definition. And third step is function call. Because without calling, a function cannot work. A function cannot execute. So here the one general syntax is given of a function definition. Take What is the general syntax? The general syntax is return data type, function name, and the argument declarations. Inside this, we have a local variable declaration, body of the functions, and the return expression if it has, because return expression is not mandatory for all the functions. And at the same time, example is given. The name of the function is look mult by 2, which is taking a parameter integer and returning a value. The return data type, the data type of the return value is integer, which is what this function is doing. The function is just taking an integer value x, multiplies it by 2, and returns the value to the caller. Just think about the situation what we consider. You appointed a person named John. You provide a machine number to John. John turned on the machine, and when he leaves the room, he informs you that machine is in on mode. So who is this person John? John is nothing but a user-defined function. What is the machine number in this case? In this case, the machine number is nothing but the parameter and the information. Matlab, after turning on the machine, when John informs you the machine is turned on, that is the return value to the caller. John cannot work with its own. John must be called by some person, X, Y, Z, whoever the person is. When he completes his task, he must return. He returns a value to the caller. But the returning value to the caller is not mandatory for all the cases. So now try to understand what is the meaning of this return data type. If the called function is return any value to the caller, means the calling function, then that return value must have some data type, and that data type is called return data type. I will give you example just after this slide. So another important thing I must have to mention here, when I declare a variable, say retval, retval is the local to the function main, sorry, to the function mult by 2. What is the meaning of this local declaration? The meaning of this local declaration is this retval is unknown to all other functions except this function mult by 2, because you declared retval inside mult by 2 function. So that's why in the general syntax declaration part, the first line is written local variable declaration. And one more important thing is the variable int x, which is written in the part of the argument declaration, that variable x also local to mult by 2 function. Understood? So local variable is a variable which is defined inside a function and which can be accessed only within the function. where it is defined. A function may or may not return a value. If it does, if it returns a value, it can return only one value. It cannot return more than one value at the same time. That is a very important point. When a function encounters a return statement, the normal function execution is stopped and control is transferred to the calling function. When John is returning value to me, John stops its work. The control of the program is coming back to my room, rather in my hand. If no return statement is there, the closing process acts as a void return. If the function is not return any value, the return type, rather the return data type of the function, the return data type of the function must be void. I will show you some programming example after discussion of this slide. A function may contain another function. Actual and formal arguments must agree in data types. I will explain what is the meaning of this actual and formal arguments in the example. A function has a single entry and single exit point. When you have entered into the functions, you cannot exit and re-enter. No, one single entry and single exit point of the functions. What is the meaning of the parameter and argument? Actually, parameters or arguments are the means of communication between the calling and called function. Again, going back the situation that we considered, where John is the person, rather John is the function. I provide the machine number. So I am the calling function, John is the called function. The communication between myself and John, how it can be done? It can be done through a parameter. What is that parameter in this case? In this case, the parameter is the machine number. Similarly, the example that we have given previous slide, that is mult by 2. When I am calling the function mult by 2, int x is the parameter. X is the parameter. So when this function mult by 2 is called by some other function, it must have to provide the calling function must have to provide an integer value x, which is used for the purpose of calculation inside the definition. So parameters or arguments are the means of communication between the calling and called functions. And the words argument and parameter are often used interchangeably. In general term, parameter refers to any declaration within the parenthesis following the function name in a function definition or declaration part. And argument refers to any expression within parenthesis of a function call. The terms formal arguments and actual arguments are sometimes used for same distinction. So I will explain this lines when I will discuss this function in an example. Very soon I'm coming with the example. These 3 steps I already mentioned to you. When I'm going to define my own function, I have to follow these 3 steps. One is function prototype declaration, second part is function definition, and third part is function calling. So this is a complete program of a using a user defined function. Try to understand. Try to understand. First line is int cube int. What is the meaning of this line? This is nothing but the int cube int. This is nothing but the prototype declaration, or rather function declaration. And What is the meaning of this line? The meaning of this line is you are trying to define a function. The name of the function is cube, which is taking a parameter, data type integer, and after execution of this function, it will return back a value. The data type of the return value must be, the data type of the return value must be integer. So return data type is integer. The name of the function is cube, and it is taking only one parameter, that is also an integer. Okay? And this is the function definition part. It is the function which is only calculating the n cube and returning the value of n cube to the caller. You have declared a local variable c inside the function cube. You are performing the cube operation n into n into n, and finally you are returning the value c to the caller. Now coming back to the calling part. So declaration part is over, definition part is there, and the calling part, that is the third one. So you are taking input x and from the main, and you are calling function cube from main function with the parameter x. Suppose the value of x is 5. You have given the input, the value of x is 5. So when you have given the value of x is 5, so it calls cube function with the value 5. Automatically the control of the program transfers from main to cube function. Fine. And the value of x is just copied to the value of to the variable n. It's a very important point. The value of the x, matlab the variable x, the value of the variable x is copied to the variable n. And previously already I mentioned the n, variable n, which is written as a parameter of the cube function, is local to the function cube. That means this n variable can only identify the function cube. This n variable is not known to the function main. Similarly, for the main function, I have declared a variable int x, which is local to function main. X is completely unknown to the function cube. That's why when you are calling the function cube, the value of x is just copied to value of n, and it calculates the value n cube by the formula n into n into n, and the calculated value is stored inside C, and it returns the value C to the caller. When it returns the value C to the caller, the result of the cube function is, that means it returns the value C, and it's just copied to the variable result, which is again local to main function. And in the very next line, what you are doing, you are just print the value of result in the program. So these two lines you can merge, and you can write in this way also. Printf %d cube x. That means in this case, matlab in the second options, you are not using any third variable to store the result. You are directly, your function cube x is calculating the value, returning the result, and that result is printed by this %d. Fine. So hopefully this three parts is clear for this program. First part is function declaration, second part is function definition, third part is function call. So now your question may arise, where we declare our function. After the line of header files all the times? No. The answer is no. You can declare your function inside main also. You can declare your function inside any other function also. Suppose you have a function A Inside function A, you have declared another function B. You have declared, I am telling you, you are not giving the definitions. You are only declaring a function B. So that declarations become local to that functions. We already explained what is the meaning of local. That means if I declare the cube function inside main, the cube function is local to main function. Only main function can identify this cube function. If there is in other functions fun cannot identify cube if you declared the function cube inside main, because that function declaration become local to the function main. Understood? So better option for us is to declare function globally. How we can declare? First, you have to give the return type. Second, I have to give the function name. And third, I have to provide the data type of the parameter list within parenthesis separated by comma. In this program, we have only one parameter, that is x. If my function has more than one parameter, then I have to write the data types of more than one parameter within this parenthesis, and that should be separated by comma. And another important thing I must mention over here, function cannot work with its own, that I already mentioned. It must be called some other functions. The function which is calling the function is called calling function, and the function which is called the called function. In this example, main is the calling function, cube is the called function. Hopefully it's clear. But function definition cannot be nested. That means you cannot define a function inside other function. In this example, what we have done, we have closed the braces of the main function. Then we started the definition. We started to give the definition of cube functions. Another questions may arise. Should I always define this function after main functions? Answer is no. Answer is no. You may define your function before main also. If you define your function before main, so in that case, you may omit the declaration part, but it's not the standard convention. Standard convention is when you're going to define your own function, that means when you are using user defined function, you must have to write all these three steps. First one is function declaration, second part is function definition, and third part is function call. So depending upon the parameter list and return type or the return value, functions can be categorized into 4 types. The first type is function with arguments and return value. Second is function with argument but no return value. Third one is function with no argument but the return value. And the fourth one is function with no argument and no return value. Important point is, if your function is non-void, what is the meaning of non-void? That means the function is returning some value to the caller. should be return a value to the calling function. And if you miss to write the return statement, then the compiler will give you an error. Function should return a value. So if your function is non-void, you must have to return a value to the caller. So these are the 4 types of functions we have. We are going to the programming example so that it will be clear to you. First, this is the function where we are trying to add 2 integers, right? This is my header file, stdio.h. My add function is taking 2 integer parameters, int comma int, and the second thing is the function is returning a value. The data type of the parameter is integer. I already mentioned earlier that if you provide more than one parameter in a function, you have to mention the data types of all the parameters within parentheses. Sorry, just a minute. You have to write all the parameters, data types of all the parameters separated by comma. So here I'm taking 2 integer parameters, so I have to write int comma int. So this is the function where parameters is there as well as return value is there. So taking a comma b, passing a comma b to the function add, and that a and b will be copied to x and y. Go to the function definition part. When it will be called, the value of a and b will be copied to x and y, and sum is the declared local variable to the function add. It do its the summation process, and finally it will return back the result, return back the value sum, and it will be stored inside variable result, and result gets printed. Second case, second example, function with argument but no return value. So we have done the same program, previous program, but without returning any value. So taking again 2 integer variables, int comma int, directly going to the definition part. So calling, when it calls the add functions, a and b will be copied to x and y, and the result is printed inside the function add. So here add function is not returning any value to the caller. That's why the return type of the add function is void. Before that it was int, because in that case the function is returning the value. The function is returning value to the caller, but in the function, in the second case, I'm not returning any value to the caller, so that's why the return type is void. And one point I must have to mention over here, that is, in this case, in this example, or rather any other function, user defined function example, the variables which you used to call, the variables which you have used to call is called the actual parameter. Here a and b is used as an actual parameter, and the variables which you have used in the case of definition, in the purpose of definition, here x and y, this x and y is called formal parameters. So a and b are the actual parameters, x and y are formal parameters. Next question is, can I give the name of formal parameters with the same as an actual parameters? Means, can I give the variable name a and b in place of x and y? What is the answer? Obviously the answer is yes. Why it is yes? Because this ab and this ab are not same, because this AB is declared inside function main, and this is local to the function main. And this this AB is functions local to add. So when you are passing the AB within from the function calling add, this value of A and B will be copied to this A and B. The address of these two variables A and this A and B are not same. I will discuss the address part of a variable in the next topic, that is pointer. Okay, so you can use the same variable name as the name of actual parameters in the case of formal parameters. So it will not be difficult to use, but try to use different name so that it will be easier to use for you in the program. Third case, that is no argument but return value. Just look this, get number is the function which is taking no argument but returns a value integer. So what is this get number doing? Get number is taking a input from user, that is inside variable A, and it is returning that integer value. That integer value is stored inside variable n, and you are just printing the variable n. So here is the example, which is actually using no argument, but there is a return statement. And the fourth case is that is no argument, no return value. Just like this, the function which is returning void and it has no parameter list. So no argument and no return type. So what it is doing, it is just prints hello India. So if you execute this program, it will show you the statement hello India. Okay. So these are the 4 types of functions that we normally use in the category of user defined functions. Sometimes we have a return value, sometimes we don't have any return value, sometimes we have a parameter, sometimes we don't have any parameters. Going to the next example. Example number 5. Example number 5 is actually, it's a swapping function. Look what I'm doing over here. I'm taking 2 integer parameter, int comma int, and I'm calling this swap function. The swap function is basically a void function. Matlab, the swap function is not returning any value to the caller. So now my question is, what will be the output of this program if I execute once I try to print the value of A and B before swapping, and the other case is I'm again trying to print the value of A and B after swapping. Consider the value of A as 5 and B as 10. So definitely before swapping, it will give you 5, 10. And you call the function swap. When you call the function swap, what is the consequence? The consequence is the value of A will get copied to value of X. Value of B will be get copied to variable Y. And now this is the code for swapping. Again, try to remember X, Y, temp. All 3 are the local variables to function swap. Understood? So you've done the swapping operations, but that is limited to X and Y. So when you print the variable, the value of X and Y, the value of X and Y gets printed, and definitely it will be the swapped value. If the value of A and B is 5, 10, then the value of X and Y will be 10, 5. But after calling the swap function, if you again try to print the value of A and B, it remains unchanged. So it remains 5, 10, because the swapping operation is performed. The swapping operation is performed between the variable X and Y, not for the variable A and B. And this type of parameter passing is called the call by value, because we are passing the parameter by value. Later on, we'll discuss the topic call by address after learning the topic pointer. In that case, I can pass the address of a variable to a pointer variable. That I will discuss, I will explain later on. So two types of parameter passing. So as a conclusion, we can say two types of parameter passing we can do in a function. One is called by value, another is called by address. So here, the examples that we discussed so far regarding functions all are by value, not by address. So this is the limitations, or rather this is the situations where the call by value will not reflect in the main function, because the value of the actual parameter is just copied to the value of the to the variable formal parameters. The address of actual parameters and the formal parameters are not same. They are local to, here AB is local to main function, XY is local to swap function. They are the completely different entity. So that's why when you are doing your swap operation between X and Y, that will not reflect it to the variable A and B, and you will not get the swap value inside A and B. That is the scenario. That is the actual case. So try to execute this program once again and show you the result. Say enter two numbers. I'm entering the value 5, 10. Look, the value of X and Y is 10, 5, but after swapping, when you are printing the value, it remains unchanged, A 5, 10. It's not showing the previous value before swapping. Don't know why. May not be saved. Again, try to execute. 5, 10. Yeah, now it is coming. First one is before swapping operation, 5, 10, definitely. Second one is XY value gets printed from function. Again, when it prints the value inside main A, B, from the main, it gives you the unswapped value, that is 5, 10. So this is called call by value, or rather this is the limitations of passing value to other functions through a value. Probably the last example of this lecture. Previously I mentioned function definition cannot be nested. Forgot to declare the functions. So the name of the function is max. It is returning a value integer and taking 2 integer as a parameter. Try to understand. Okay? But function call can be nested. That is the point. Function call can be nested. Through this example, I'm just showing that part. Here, I'm calling max function inside a max function. When you are writing the nested call, the working principle is the inner function will be executed first. So here, actually the function definition says the max function will return maximum of 2 integers. So here I have 3 integer value A, B, C, and I passed A, B from the first max function, which will give you an integer, means which one is the maximum among A and B. That return value will act as the first parameter of the outer max function. So you are passing 5,6 over here. Inside, in the first max function, you are passing 5,6. It will give you value 6. Fine. And second times when the outer max function is called, it taking parameter 6, 7. This max function is written 6, 7, and finally you will get back the result value 7, because 6, 7, from 6, 7 it will give you return the value maximum of 6, 7, that is 7, and that is stored inside D, and you will just print D over here. And that is the definition part of the max function. If x greater than y, it's x is stored inside z, else y is stored inside z. Ultimately you are returning z. Try to execute the program. Execute, compile, run, will give you 7, maximum equal to 7. Fine. So returning back to the slide once again. Categories of functions we already discussed. Parameter passing, 2 types of parameter passing we can do. One is called by value or pass by value, that I just discussed in the example of swap function. Call by reference or pass by reference will be discussed this topic after discussion of the pointer. Next, function within a function. So function call can also be nested, that we have already give you example. In the place of actual argument, we can call the function. And in the case of nested function that I already mentioned, in the case of nested function, the inner function call is the first executed. That means the inner one will be executed first, then the outer one. So thanks for your patience. Thank you all. So in the next lecture, we'll start discussion about the recursion. Thank you all again.